studied the name reaction from the haloalkane and haloarene, that is Finkelstein reaction and Schwarz reaction. So in today's class we will discuss the chemical reactions of haloalkane and haloarene. So first of all we will discuss the reaction of haloalkanes. So whatever the chemical reaction of haloalkane is there, that is having mainly three types. One is there nucleophilic reaction. Second one also it is called nucleophilic substitution reaction. Second one elimination reaction, and third one reaction with metal. In the today's class we are going to discuss nucleophilic substitution reaction. So what do you mean by nucleophile? Already we studied in the QC first year what is nucleophile and electrophile, and then I will come towards the nucleophilic substitution reaction. So let's understand what do you mean by nucleophile. Nucleophile are those entity, are those species which is having negative charge. They always move towards the nucleus. Also it is called nucleus loving species. For example, OH minus, NH2, these are all example of nucleophile. Then what do you know nucleophilic substitution reaction? The replacement of halogen atom of an alkyl group by nucleophile like OH minus is called nucleophilic substitution reaction. Here halogen atom like ClBr, it can be replaced on the alkyl halide by using nucleophile as OH minus, are called nucleophilic substitution reaction. See here Nu minus, what it indicates? Nu minus, it is nucleophile. This is the alkyl halide. We already know the nature of the CX bond. In the haloalkane, CX nature shows that due to presence of halogen atom, due to more electronegative atom present on carbon, it shows carbon partial positive charge and halogen partial negative charge due to high electronegativity of halogen atom. So Nu minus, when it is substituted on the carbon by removing halogen, and it gives CNU by breaking the CX bond. This is called nucleophilic substitution reaction. So right now we will discuss some reaction of haloalkane with nucleophile. The first reaction we studied here. So given alkyl halide, where it is reacted with the aqueous KOH is potassium hydroxide. It gives ROH plus KH. What means this ROH? ROH is called alcohol. So I will write the reaction. So how actual reaction will going to happen? I shown on the board general example. So here, so R I will consider as a CH3 and halogen I will consider CHCl. This is called chloromethane or methyl chloride. When this methyl chloride, when it is reacted with the aqueous KOH, so what it gives? It gives alcohol as product. So here R it is a CH3 group. So you will get here product CH3OH plus KCl. You will get methyl alcohol as a product. So next reaction, when a given alkyl halide is treated with aqueous NaOH, it gives alcohol as a product by elimination of sodium halide. This is the general example. In this example also I am going to consider R as CH3 group. Am I right? CH3Cl plus I will write aqueous NaOH, product gives CH3OH plus NaCl. So this is called alcohol, methyl alcohol. This is also alcohol. So next reaction, when given alkyl halide is treated with a alcoholic potassium cyanide, it gives alkyl nitride as a product by elimination of KX. So I will write here. Here also I will consider R as a CH3 only. I will write CH3 Cl. X I will consider as a Cl. Then I will treat with the KCN, potassium cyanide, in the form of alcoholic. What do you mean by alcoholic? Means what is the potassium cyanide is there, that is prepared in the alcohol. So what it gives? It gives R into the CH3 group, CH3 Cl plus it gives KX. So X is the halogen, Cl it is there, so it gives KCl. So this is called ethane nitride. What it is called? Ethane nitride. Well, so next reaction is that when alkyl halide is treated with alcoholic silver cyanide, alcoholic AgCN, it gives alkyl isocyanide as a product by elimination of AgX. So here I write R also CH3. Here I write Cl. R will treat with the AgCN, silver cyanide, in the alcoholic form. So it gives CH3 NC plus AgX. CX it is the halogen. It gives AgCl. So this is called methyl isocyanide. This is ethane nitride. This is called methyl isocyanide. Next, when a given alkyl halide is reacted with silver salt of carboxylic acid, when given alkyl halide is treated with the silver salt of the carboxylic acid, it gives ester as a product by elimination of AgX. I will write the actual example. Here also I will going to consider R as a CH3. So here also I will write CH3Cl, nothing but either chloromethane or methyl chloride as a haloalkane. When it is reacted with the silver salt of the carboxylic acid. So here also I am going to consider R as a CH3, and there I will write as a silver salt of the carboxylic acid as a CH3COOAg. When it is having a reaction, so what it gives? It gives as a ester as a product. So here I will write the ester. In the general example, we use CH3COOR plus AgX. So here I will write CH3COOCH3 plus I will write AgX. X is the Cl, so that's why I will write the AgCl. This is the ester. Next reaction, when a given alkyl halide is reacted with the potassium nitrite KNO2, so it gives alkyl nitrite as a product by elimination of KX. I'll write the actual example. In this example also I am going to consider R as a CH3. I'll write CH3Cl as alkyl halide. When it is reacted with the KNO2 potassium nitrite, it gives alkyl nitride as a product. Being an alkyl as a CH3 group, it gives CH3O NO plus KCl. This is called methyl nitride. Next reaction, when a given alkyl halide is reacted with the silver nitride, when it is reacted with the silver nitride, it gives nitroalkane as a product by elimination of silver halide. So I will write the actual example. In this example also I will want to consider R as a CH3 group, and there I will write CH3Cl plus silver nitride AgNO2. It gives CH3NO2 plus it gives AgCl. So this is called nitromethane. So these are the reactions of haloalkane, that is called nucleophilic substitution reaction. So these are example, all are important for the examination point. So in these all example, just only I considered R as a CH3 group. You can try by considering R maybe the C2H5 or propyl group or butyl group. We can consider different kind of the alkyl group and try to solve the reactions. You will get a different product. I comparing with a general example. So right now we are going to discuss types of nucleophilic substitution reaction. So in the types of nucleophilic substitution reaction, mainly two types of nucleophilic substitution reactions are there. So one is the SN1 reaction. In the types of nucleophilic substitution reaction, we will discuss one SN1 reaction and second one SN2 reaction. These are the two types of nucleophilic substitution reactions are there. I want to clear here. This SN1 and SN2 reaction and reaction mechanism are very important for the examination point. Out of these two mechanisms, in the examination you will get one mechanism for 3 marks. So it is a very important for the examination point. So what do you mean by SN1 reaction? What is SN1 and what is SN2? So first one, we will understand what is SN1. SN1, nucleophilic substitution unimolecular reaction. One stands for order. Nucleophilic substitution unimolecular reaction. And second one, nucleophilic substitution bimolecular reaction. So what 1 and 2 indicates? 1 indicates the rate of the reaction, order of the reaction, and 2 indicates that order of the reaction by the SN2 reaction. Well, so first of all, we are going to study what do you mean by SN1 reaction and what do you mean by SN2 reaction. Then we are going to study the mechanism. So in the SN1 reaction, nucleophilic substitution first order reaction or unimolecular reaction in which given tertiary butyl halide, when it is reacted with aqueous NaOH, it gives tertiary butyl alcohol as a product by elimination of NaX are called SN1 reaction. So in the SN1 reaction, the tertiary butyl halide, when it is reacted with the NaOH, it gives tertiary butyl alcohol as a product by elimination of NaX. This is called SN1 reaction. What is the SN2 reaction? In the SN2 reaction, given primary alkyl halide, that is methyl chloride. In the SN2 reaction, given methyl chloride or given methyl halide, it's treated with NaOH, it gives methyl alcohol as a product by elimination of NaX are called SN2 reaction. So here alkyl halide, alright, methyl chloride, simply methyl chloride, alright. The given methyl chloride is treated with the NaOH. It gives methyl alcohol as a product plus NaCl. So this is called SN2 reaction. So why it is called SN1 and SN2? In the SN1 reaction in which the rate of the reaction is depend only on the nucleophile. So the concentration, how the order it can be calculated, sum of the concentration of nucleophile as well as the substrate. So here in the SN1 reaction, rate of the reaction is depend only on the concentration of nucleophile. So that's why it is called unimolecular nucleophilic substitution reaction. What about SN2 reaction? In the SN2 reaction, the rate of the reaction is depend on the concentration of the nucleophile as well as the concentration of the alkyl halide. So if I sum of that, if I want to calculate the order of that, the concentration of the alkyl halide plus concentration of the nucleus, 1 plus 1 is equal to 2. So that's why it is called bimolecular nucleophilic substitution reaction. So let's discuss right now the reaction mechanism, SN1 reaction mechanism. What do you mean by mechanism right now? We studied right now the reaction, SN1 reaction. What do you mean by mechanism? So in the reaction, how the reaction it is carried, for that the step by step learning that is called reaction mechanism. So let's study SN1 reaction mechanism, which is very important for the examination point for 3 marks. We will discuss right the mechanism. We know right now what do you mean by SN1 reaction. The SN1 reaction, given tertiary butyl halide is treated with aqueous NaOH. It gives alcohol as a product, that is the tertiary butyl alcohol plus NaCl. So we will discuss the reaction mechanism. In the reaction mechanism, in the SN1 reaction mechanism, the reaction is explained in 2 steps. The first step is that formation of carbocation, and second step is that attack of nucleophile on the carbocation are called nucleophilic substitution reaction mechanism. So we are going to study step by step. So we know the reaction. So what is the reaction is that in the SN1 reaction, given tertiary butyl halide, halide is a chloride, tertiary butyl chloride, is treated with NaOH. In this case, OH minus is a nucleophile and it gives CH3, OH plus NaCl and product. This is called tertiary butyl alcohol. This is the reaction, this is not a mechanism. Let us discuss the mechanism. In the mechanism, SN1 reaction explained in 2 steps. The step 1 is the step 1. Tertiary butyl chloride ionizes to form carbocation. This is the first step. So it is the tertiary butyl halide, tertiary butyl halide, CH3 halide, here halide the Cl. I will treat with undergo the ionization. It gives CH3 halide they both be charged plus halide Cl minus. This is called carbocation. This is highly unstable and planar in nature. The hybridization of this carbon atom is sp2. This is the first step. What is the first step? The given tertiary butyl halide or chloride undergoes ionization. It gives carbocation. What do you mean by carbocation? It's very important. Carbon atom possess positive charge are called carbocation. Plus it gives Cl minus. This is the first step. In the second step, I'll write the second step. Step 2, I will write. Step 2, the liquefied OH minus. The liquefied OH minus from aqueous NaOH, attacks on planar carbocation, on either side to give tertiary butyl alcohol. So in this case, in this mechanism, so I will going to write carbocation. The carbocation which is planar in nature, carbocation. I write the OH minus as a liquefied from NaOH. Due to planar carbocation, this OH minus will attack one side also and that side also. So it used as a product. Alright, the carbon, here I write the CH3, here I write the CH3, here I write the CH3, here I write the OH. OH I write. So this is called tertiary butyl alcohol. And another product also I will write here. I write CH3, CH3, CH3 and OH. Means two products will get, that is called a racemic mixture. In this SN1 reaction, the reaction gives a racemic mixture. Okay. So next we are going to study the another reaction, another type of the reaction, that is a SN2 mechanism. SN2 mechanism. We know SN2 reaction. In the SN2 reaction, the given methyl chloride is treated with the aqueous NaOH. It gives alcohol as a product, that is methyl alcohol, are called SN2 reaction. Alright, the reaction first of all, the given methyl chloride, you can change X, maybe the Cl or Br. I write the methyl chloride. I will treat with NaOH. It gives CH3 OH plus NaCl to get methyl alcohol as a product. Methyl alcohol. We'll study mechanism. What do you mean by mechanism? Study of this reaction in step-by-step method. It's called mechanism. So in the SN2 mechanism, the reaction is explained in only one step. So in this step, so whatever the nucleophile OH minus is there, this OH minus, it will going to attack on the electron deficient on the carbon atom, and in the one step only, it will going to form partial COH bond and partial CCl bond in the transition state. Means in the SN2 mechanism, in only one step, forming and breaking a bond takes place and it gives corresponding alcohol as a product. So how the reaction is explained? I write CH3 first of all, I write the H, I write the H, and here I write the Cl. Nucleophile will attack, I write the OH minus. This nucleophile will attack on the partial electron deficient of the carbon atom, and in transition state it gives OH bond, and here I write the Cl bond. This is happening in the transition state. And the higher energy level in the transition state, it gives new OH bond and new Cl bond. Breaking and forming takes place. Here the bond will form as a COH and bond will break as a CCl, and it gives as a product OH, C, H, I write here H, here I write the H, plus I will write as a Cl minus. This is called methyl alcohol. And in this case, the product is used as an inversion product to make it. Okay. So these reaction also, it is a very important for 2 marks. Sometimes in the examination they will going to ask, write the difference between SN1 reaction